All right, so we need to talk a little bit about section properties and then something called the current point. So let's talk with section properties here. We were talking about using the area when I talked about stress. And let's say you have a beam. We can make it a T or an I or a rectangle or whatever. But we have this beam and it has some area of pre-stress, which may be a multiple strands, but I'm just going to represent by a dot there. So that's the area of the pre-stress part in the cross section. And we know when we're calculating stresses and deflections and things like that, when the beam is uncracked, things tend to be a lot more simple. Technically, we should, to get the most precise answer, be using transform section properties. So you get an I transform, which would be, remember this thing from mechanics and from the deflection calculations of uncracked sections in our concrete class. So that would be N, and that's in the modular ratio. So N, as you recall, is the E value, the modulus of elasticity of the steel, in this case the pre-stressed steel, over the modulus of the concrete. And you multiply that to transform the steel into equivalent concrete. But we can also use I gross for most situations. And I gross is if you turn the concrete portion or the steel portion completely into concrete. So you just use the gross full section area of so the whole deal, no hole in it, of the concrete. And for most of our calculations, this will be adequate. If you had a very large amount of pre-stressing steel in a section, you would probably be better off using the I transform, but in most of the sections, and particularly in the ones that we're doing in class, I gross will be fine. All right. In addition to talking a little bit about that, let's talk about something you may hear as you move along, and this is called the Kern point. I don't tend to refer to this a lot, but it's something that you'll see in a lot of textbooks and something that some designers are referred to. And the Kern point is simply, you take it whatever kind of section, rectangular, what have you. The Kern point is simply when you have the effect of the pre-stressing steel. So this is the pre-stressing steel part, which would be a stress of PE over S, as we talked about before. And then you have the P over A part, the pure compression part. It's also going to be a compressive stress. And when you add those two together, if you get a section where the tension part is 0, and this is, the rest is in compression, stress of the bottom, bottom pre-stress. The key here is that when you have the tendon located at a certain distance, E, where this value plus this value equals 0, then you are at the Kern point. So if we looked at this, let me move this down a bit. If we look at this, we'd have a place where PE over S is equal to PA, equal and opposite basically, so they sum to 0. Cross out the P, you get E equals S over A, and so that would be equal to, for a rectangular section, would be equal to BH squared over 6 over A equals, get out of BH, you get AH over 6 equals the eccentricity of the kern in a rectangular section. Okay, so you don't need to memorize this, but this just gives you an idea of someplace a good starting point. If you're trying to figure out where to put a tendon, you can put it in that kern section. But I will probably not talk about that too much except for when we're just starting to pick out some pre-stress locations.